AP Physics 1 Workbook, Unit 4, Work and Energy. Activity N, Potential Energy of Systems. Please remember to pause or rewind the video as necessary. Read the scenario along with me, please. 3 identical springs, A, B, and C, each with an unstretched length of 1 meter and a spring constant of 2 newtons per meter, are attached on the edge of a circular hoop with a radius of 4 meters, as shown in Figure 1. The hoop is lying flat on a desk, and we are looking at it from above, so we can ignore gravitational effects on these masses, since all the gravitational effects will be the same. A small object is attached to each spring and comes to rest in the center of the hoop. How much work was done on the spring object system while attaching the springs to the center object? So basically, you can see in order to attach to that center object there, you had to stretch that spring, and that spring. So in other words, the work done is equal to the spring or elastic potential energy. Since you have 3 springs, it's going to be 3 times the spring energy. So let's do the work first. The work on the springs, the work on the system. Is going to be equal to the change in potential energy of the springs, all of them, which is going to be, since they're identical springs, 3 springs times 1/2 kx squared, which would be 3 halves times k. K was 2 newtons per meter, times the 3 meters you stretched it, squared. Okay, because we have a radius. We were told it has a radius of 4 meters, but the spring already has a length of 1 meter to begin with before you stretch it. So that means the stretched length, x, would be the remaining 3 meters. Okay, so we can see that the 2's are going to cancel here, and we have 3 squared is 9 times another 3 would be 27 joules of spring potential energy for the entire system. Let's go ahead and summarize that. The work done on the springs will account for the increase in spring potential energy that the system now has. Note that each spring, that should be spring, not string. Each spring stretched 3 meters from the original 1 meter length to a total for a total of 4 meter radial distance. Since work is a scalar, as is potential energy, so the total potential energy stored in the system is the sum of the potential energy of each object spring system. This will equal the total work done on the system, which, as we found to be 27 joules. Figure 2, the mass has been given a horizontal displacement of 3 meters relative to the center of the hoop by an external force. A student measures the resulting lengths of each spring, as shown in the diagram. Did the external force do positive work, negative work, or no work on the mass spring system? In a clear, coherent paragraph, explain your choice above. Well, let's figure out what's going on first, and then we'll write about it. So we're going to separate this into each springs, okay? Each spring. So, for instance, you'll notice spring A has been stretched from 1 to a certain amount, okay? And we can figure out these amounts using a little bit of Pythagorean Theorem. And so stretch B is stretched a certain amount, and then C is probably stretched a certain amount as well. So it's moved 3 meters this way, so we have a total of 4 meters, 4-meter radius. We moved this 3 over, so we can see this triangle that's formed here. And if that's 3 and that's 5, using a little bit of Pythagorean Theorem, let me see here. Okay, so we can see that 5 is this length right here, which means if that's the new length, that means x, where the original length was 1 meter. So if the new stretched is 5 meters, that means XA, I guess we can call it XA, would be 4 meters, right? It's going to be 1 meter less than that. B, if B stretched to 6.8, that means XB would only be 5.8. And then same thing with C. XC has stretched to 2 meters, therefore XC, the actual stretch length is only 1 meter. Okay, and so that's what we're going to find, is we're going to find the potential energy of the system, which we can't go 3 times like we did last time. We're just going to have to add them up. So it's the potential energy of A plus the potential energy of B plus the potential energy of C. So we're going to go 1/2 times 2 times A stretched to 4 meters plus 1/2, same spring constant K, 2, times 5.8 squared plus 1/2 times 2 times 1 squared. Go ahead and pause the video, take a second to put that in your calculator, and let you match results in a second. Okay, so the new spring potential energy, right, is 50.6 joules. Let me say 0.64, I guess. Now, the question was asking, was work done on this? Well, think about it this way. The potential energy, I'm going to call this U system prime. The original U of the system was 27 joules and now increased to 50.6 joules. Since work on the system of springs is equal to a change in the potential energy, and the potential energy increased, that means work is positive. Okay, now that we took some time, it's always good before you write your paragraph length response to take some time to either calculate your way through it, use various equations and symbols to try and work your way through the brainstorming, okay? And then you can have something very coherent to write about. The work done by an outside force would need to be positive if the system's stored energy increases. And you can see it did. It increased from 27 to 50.6. We can find a change in potential energy of each spring from the equilibrium condition to the current condition. If the net change is increased, then the force must have done positive work. And it did, in this case, do positive work.